I'm pleased to be joined today by Dr. Mark Solms. He is a neuropsychologist and a professor at the University of Cape Town in South Africa, and the author of The Hidden Spring, A Journey to the Source of Consciousness. Dr. Solms, welcome to the Nature and Nurture podcast.
Thank you very much. I'm glad to be here.
Thank you very much for taking the time to speak with me. So, Dr. Solms, you're addressing what you define and what many define as the hardest problem in the world, possibly consciousness. How did you decide to tackle such an amazing problem?
My interest in the field of neuropsychology started with, I think, the same sort of naive wonder as many children experience. You know, how come I am my body? What is the relationship between me and my body that has all sorts of implications, not least of them mortality. I was confronted by this problem a little earlier and a little more dramatically perhaps than most, because my older brother, when I was just going on 5 years old, my older brother sustained a brain injury. And so I saw him changing, you know, from one person to another. And this was my kind of induction into the field. You fast forward 14 or 16 years from there, and I trained in neuropsychology and was rather disappointed by how desiccated it was, you know, how denuded of anything truly mental. And so I think that's the origin of my interest in subjectivity. It's not quite the same thing as consciousness, but I think I, more than most of my colleagues, wanted to bring the lived life of the mind into the field. And so that's the sort of broad answer to your question. There's a narrower answer, which is that I then went on to research brain mechanisms of sleep and dreaming, which of course has everything to do with consciousness. Sleep versus wakefulness, and dreaming versus unconscious sleep. I mean, the central thing about dreams is the paradox that we're asleep and yet conscious. That's what dreams are. And so that in a more kind of concerted way drew me into the study of brain mechanisms, specifically of conscious states.
Mm-hmm. And I saw that you also have a background in psychoanalysis. Is this what you were talking about when you said that your study of neuropsychology tended to be to have the life drawn out of it? It seems like that's a perspective that has more so fallen out of fashion in the last, I don't know, century.
Oh, yes, it was very much out of fashion, even when I became interested in it. So I trained in neuropsychology in the early 1980s. And then already psychoanalysis was what in Latin one might say scientia non grata, a unwelcome science. And the reason I trained in psychoanalysis was largely because of the frustration that I just mentioned. You know, I thought, you know, where's the psyche in neuropsychology? And looked around, and for all of its faults, and, you know, I really do need to concede that psychoanalysis has many faults. For all of those faults, at least it took as its starting point the lived life of the mind, you know, actual experience of being the mind. And so my intention in training in psychoanalysis was to see what I could learn from them, so that I could bring something of the subjective perspective, the language, the concepts, even the methods that psychoanalysis developed, bring them into neuroscience, not, you know, unchanged, because of course, once you start bringing these things into neuroscience, you start requiring a more rigorous approach to them. But it was a starting point for me. I have to say also that my early research on the brain mechanisms of dreaming led me to take rather more seriously than we were taught to, what the psychoanalytic approach had yielded. Because my first and happiest in some ways discovery was that the brain mechanisms of REM sleep, in other words, the pontine mechanisms that had been identified by Jouvet and Hobson and others, that when you study these mechanisms in human beings with brain lesions to those structures, you find that they continue to dream, that there's a double dissociation between dreaming and REM sleep. In other words, you can have damage to pontine structures, which leads to a loss of REM sleep, but dreaming persists. And then there are patients with damage elsewhere in whom dreaming is lost, but REM sleep persists. And that elsewhere that I'm referring to turns out to be the mesocortical, mesolimbic dopamine system, which has everything to do with motivation and reward and affect. And so that made me interested in what the psychoanalysts were saying about dreams being motivated mental states. So I think I probably took them a little bit more seriously than I might have because of those early discoveries of mine. But the broader context was what I said: frustration and disappointment with neuropsychology, at least in the 1980s, with its lack of, it not taking the first person perspective ever.
Wow.
And
So
if I may add, sorry, Adam, I'm interrupting you, but if I may add, what is a mind if not first and foremost, something subjective? If you can't take the first person perspective on the mind, how are you going to study it?
Mm-hmm. Right, and there's kind of this paradox, because if something is subjective, then it's not objective, and science is supposed to be objective.
Exactly. The mind is an embarrassment to science, as we learned from decades of behaviorism. They literally excluded the mind from psychology in order to be objective. So I think that in our times, unlike the early 20th century when psychoanalysis was developed, we don't have to be so wary of subjective states, because we don't have to study them in isolation. We can study subjective phenomena objectively. In other words, we can look at a subjective mental state from the viewpoint of what its brain correlates are. And I think that we can therefore be a little bit less wary, because we are tethering our observations of a subjective kind to parallel observations of an objective kind, and thereby we have more methodological constraints than they had in the early days of developing the psychoanalytic perspective.
Mm-hmm. So in the last few decades, has the field made any larger shift towards appreciating this subjectivity?
Oh, yes, and it's not only my doing. I mean, it just happened when I came in the 80s. It was, honestly, when I started to ask my professors questions about where is the self, and what about emotion, and and so on, I was seriously advised not to ask questions like that, and told that it would be bad for my career. That's where things stood those days. In fact, there was a book that came out in the 1980s by Hellman and Satz called The Neuropsychology of Emotion. And I swear it was the very first one. By the way, it was a terrible book, but it was the first one. In the 1980s, I think people of this century don't realize just how bad it was. But then there were people. I think a pivotal figure was Jaak Panksepp, the affective neuroscientist, who studied very seriously brain mechanisms of emotion. And then there was, from your own university, Antonio Damasio. He did a very great deal. And, although he was not a proper scientist, Oliver Sacks was, I think, also made made many people, I mean neuroscientists, a little more interested in the subjective experience of neurological patients than they might have been before that. So although that was in the sort of popular literature, nevertheless, I think it had an effect. And so, by the late 1990s and early 2000s, the situation was changing. I think we are seriously, we're living in a golden age of neuroscience right now, where we are really very courageously and with a sense of sort of adventure and wonder, beginning to address the big questions.
That's fantastic. Yeah, there's so much there. I remember it was very eye-opening to me reading Damasio's Descartes' Error, which I think was written in the 90s, and how much of this was presented as new and groundbreaking and speculative. And this is stuff that I had been learning in my intro classes already in 2020 or so. So it was a lot of progress has been made, it sounds like.
I agree.
So I'd just like to ask you a few more things about dreams before we go on to talking about the bigger problem, consciousness. So I guess on two extremes, you could have people on the more cognitive end who believe that dreams are just random brain firing, they have no meaning. And on the extreme Freudian end, you might say dreams are this massive source of untapped potential that can reveal so much about who you are. I'm guessing the truth is somewhere in between. What do you think about it?
Yeah, I agree. So the work that led me to take the Freudian perspective more seriously certainly was not of a kind that confirmed each and every speculation of Freud's. It just made me realize that actually the fundamental findings that had led us to discredit his approach entirely, namely the fact that, just as you put it, if dreams are driven by the mesopontine tegmentum and cholinergic activation of the forebrain, like clockwork, automatically, every 90 minutes it switches on. Then, why would you expect that there's anything mental involved? Those are very lowly mechanisms. There's nothing motivational about them, and they function autonomically. When I realized that those findings themselves were wrong, that means, well, then you have to go back to what has been discredited and look at it in its own terms. In addition to the fact that what does drive the dream process is as I mentioned a moment ago, these mesocortical, mesolimbic dopamine systems, which have everything to do with motivation. So you build from there, the dreaming brain, if I can just sketch it in its simplest outline, it's characterized by, first of all, massive activation of the mesocortical, mesolimbic dopamine circuits, coupled with very substantial deactivation of prefrontal cortex. So what you have there, and when I say mesocortical dopamine, it's not only that circuit, they're also all the limbics, as we loosely call them, all the limbic structures are really lit up like a Christmas tree during dreaming sleep. And that includes the hippocampus, which of course is so central to autobiographical memory. So the idea that dreams are motivated, that they have something to do with emotions, and that there's some personal memory processing going on in it, that I think all of that is reasonable. Beyond that, to say, dreams are disguised representations of repressed wishes and whatnot, my findings, and as far as I'm aware, nobody else's findings support that. It's just that, they're not random. There's no reason to believe that they're mindless, that they reveal nothing about the motives and current concerns, of the dreamer. I think that that's the kind of middle ground that you're referring to, that I think that we can more or less all of us agree on.
Right. And the brain is very energetically costly. So it seems like if it's activated in this way, there must have been some survival benefit looking at it from an evolutionary perspective.
Oh, yes. That's a very interesting question. We spend about 20 to 25% of our sleeping hours dreaming. Why? It's a large portion of our lives.
very interesting. So, where has the field of dream analysis gone since in the last few decades, and not analysis, more like the neuropsychological study of dreams? And what caused you to pivot from it and towards consciousness?
Well, to answer your first question first, the sorts of things, once we moved away from the idea that it's just random activation, of cortical networks, and started to recognize that these memory and emotional structures are so selectively involved, the two main themes developed. One of them is the idea that there's some sort of emotion regulation function. And that starts with the work of Rosalind Cartwright, where she shows, for example, that the affect in dreams predicts. These were patients, not patients, they were research participants who were getting divorced. And she was able to predict from whether the affect improves over the night from one dream cycle to the next, whether it improves or not. She was able to predict who was going to become depressed. So that was the starting point of this theme, that a dream seemed to perform some affect regulatory function. Mm-hmm. The other major trend was about memory consolidation. It became increasingly obvious that something important with respect to memory consolidation is going on during sleep. Something different is going on in the different stages of sleep. Therefore that, it's not a great leap if you think about the experience of dreams, that memory consolidation of some kind is implicated by the dream process. Now, if you take those two themes, affect regulation on the one hand, and memory consolidation on the other, there's an area in which they overlap, which is the idea that there's also some sort of problem solving going on in dreams. And the why I say they sort of overlap there is that, what is memory consolidation? It is consolidating what you learned today, what updating of your model of the world has been demanded by the events of the day. And then on the other hand, when you say that it's about affect regulation, well, what we feel has a lot to do with our problems. Are things working as expected, or are things, is uncertainty increasing? Things are not, I do not have an adequate predictive model of the world. So it's in this sense that I think that memory consolidation and affect regulation might coalesce around this idea that there's some sort of problem solving, some sort of dealing with the events of the day, the remembered events of the day, processing them affectively. In other words, there's some motivational process involved in this business of updating your model of the world.
So once you update your worldview, your emotions shift in the sense that something that was good might become bad, or something that was bad might become good, and you have to prepare yourself for that.
Yes, we are not indifferent to whether our beliefs are confirmed or not.
This does seem like a nice transition into the idea that feeling is central to consciousness, the idea that you can't just be neutral to any stimulus. But maybe before we get there, we could talk about what led you to transition into studying studying consciousness.
Yeah, well, it was pretty much along the lines of what you've just said. I must tell you something else about the neuropsychology of the 1980s and 90s. It was entirely corticocentric. In fact, another word for neuropsychology was higher cortical functions. That's what neuropsychologists studied. And so the idea that subcortical, and by subcortical, I don't only mean basal ganglia and whatnot, but even brainstem structures, might have some interest to neuropsychologists is again something that is now generally recognized, but it wasn't the case in those days. Mm-hmm. So I studied dreams. I did a large study of the effects of focal lesions upon dreaming. And what I expected I would find, which is a reasonable enough expectation, is that damage to different cortical regions would have differential effects on the content of dreams. So that, for example, patients who cortically blind, might not see anything in their dreams. Patients who are hemiplegic, will they be hemiplegic in their dreams? Patients who are aphasic, presumably can't speak in their dreams. These were the sorts of things. And what is the difference between left and right hemisphere lesions in terms of the effects on dream content? I was not expecting to find anything down in the brainstem, apart from the fact that REM sleep drove the whole process. So what I found was, first of all, REM sleep does not drive the whole process. And secondly, that the structures which do are these affect generating structures that I mentioned earlier. I'd said the pivotal one is the dopaminergic aspect of the medial forebrain bundle, but it's not the only one. All of those limbic structures are activated. So I became interested. Remember, my starting point was why dreams were interesting was because they were conscious states that punctuate the unconsciousness of sleep. Now I was discovering that those conscious states were fundamentally affective states. So I was driven to become interested in affect, and in particular, to become interested in how affect was bound up with the very brainstem structures that are the foundational font of all consciousness. So reticular activating system, to be specific, which we had previously seen as being responsible only for the level as opposed to the contents of consciousness. We thought of brainstem mechanisms as just being quantitative, like how much wakefulness is there. These findings were leading us to the view, I say us because it wasn't only me. I mentioned Panksepp. Damasio gradually shifted. Damasio is to be credited for two things. The one is that he took emotion seriously in the 90s. And then secondly, in the early 2000s, he started to realize, hang on, this is not cortical. These are brainstem mechanisms. So my dream research led me to the same conclusions, that the mechanisms that generate consciousness generate affect. And so it was via my dream findings that I became interested in consciousness, from the point of view of its intimate relationship with feeling, and from the point of view of its deeply subcortical anatomical substrata.
Mm-hmm. It seems like some of the best findings in science are when they come convergently from different areas.
Oh, yes.
I'm very surprised that during this time there weren't objections by evolutionary thinkers looking at complex behaviors of animals and thinking they don't have these prefrontal cortexes like we do, but look at them, they're clearly conscious.
Well, I'm glad you say that, because to me, they're clearly conscious, but that was not a widely accepted view at all in the 80s and the 90s. I think that a major error, perhaps that's too strong a word, but a major impediment to consciousness research was that we took our model example of consciousness to be our own human form, which is the most complex example of consciousness that there is. And so, of course, if you equate consciousness with the kind of reflection, the philosophizing that we do, if you think that's what consciousness is about, well, of course, you're going to only think of it as something that humans possess. But if you recognize that raw feelings like hunger and rage, and sleepiness and pain and so on, that these are, of course, quintessentially conscious states. They are this word qualia. What is a feeling of pain, if not a quail? What is a feeling of sleepiness, a feeling of hunger, etc.? These are clearly qualia. And there's no reason to expect that these sorts of things are uniquely human. You couple that with the recognition that actually these are the foundational forms, because remember, the reticular brainstem is a reticular activation is a prerequisite for all of the higher forms, the cortical forms of consciousness. You're led to the view that the fundamental variety of consciousness is raw feeling. Raw feeling is by no means a uniquely human thing. In fact, we, if anything, are uniquely sort of we have a unique capacity to suppress, to inhibit, to override raw feeling. But raw feeling, all of the evidence, as you say, multiple lines of evidence using different methods converge on the conclusion that this is the fundamental form of consciousness, and therefore there's no reason to believe that it's uniquely human.
Mm-hmm. So it sounds like this was a paradigm shift, not only in how we treat the study of consciousness, but what we even thought consciousness is, thinking of it more so as raw thinking and feeling, as opposed to, I guess, these higher cortical functions that sound more like intelligence to me.
Yes, exactly.
Okay, so what happened next?
What happened next, you mean in my own work?
Yes.
Well, so I started to, I became very closely allied with Jaak Panksepp. He became a very good friend. We did a lot of work together on all sorts of things, ranging from the sorts of basic science things we're talking about now. Mainly, he worked with deep brain stimulation of other mammals, particularly, not exclusively, but especially rodents. From that side of the spectrum, all the way through to human psychiatry, we worked together for a good deal of the last years of his life, because he died in 2017. We worked together on brain mechanisms of depression, and then everything in between. He was a bigger influence on me than anyone alive or dead. In other words, I include Freud. I think Panksepp really influenced me more than Freud. But then, when you ask what happened next was overlapping with the last years of Jaak Panksepp's life. I became acquainted with the work and then with the person of Karl Friston. The pivotal issue or points are the following. Once we go down to the brain stem and say, well, if the basic form of consciousness is feeling, then if we're searching for the mechanism whereby consciousness is generated, our task has suddenly become a lot simpler, because feelings are very simple things. Your colleague at USC, Antonio Damasio, more than anyone, drew our attention to the fact that affects are basically homeostatic regulators, that to the extent that you deviate from your homeostatic settling point, to that extent it's bad. It means that your viable bounds are being exceeded, and that the way that the animal becomes aware that its current state is bad for it is that it feels bad. And so the idea arose that the basic function, and I emphasize basic function of consciousness in its elemental form, feeling, is to alert the animal to how it's doing, well or badly, within a biological frame of reference. So in other words, the values of it's good to survive and bad not to. That this is what so feelings announce to us, broadcast to us how things are going in relation to our component homeostatic needs. So with that in the back of my mind, I read a paper that Friston wrote in 2013 in one of the journals of the Royal Society. It had the intriguing title, Life as We Know It. And what he outlined in this paper was a sort of fundamental mathematical formalism to account for homeostasis, how homeostasis works. So what hit me like a ton of bricks at that point was that if we can reduce the mechanism of feeling to a formalism like that, in other words, we truly are speaking about the causal mechanism, how feelings are generated, and we can reduce it to what he called the free energy principle, which, if you like, we can go into. it dawned on me that here we have, if the mechanism of homeostasis can be so treated, then surely the same applies to affect, because affect is, just a form of homeostasis. And so I started to, first of all, acquaint myself better with his work, and then eventually to collaborate with him, to try and extend what he had learned about the brainstem mechanisms or the basal mechanisms of homeostasis, to extend those principles to an understanding of how consciousness arises, consciousness defined as feeling. So that's what happened next. That was in the last few years of my working life, that has been the single biggest development. That is to say, becoming acquainted with and collaborating with Karl Friston.
Would you say that consciousness is feeling, or that feeling is an emergent property of consciousness that has to do with this homeostatic regulation and affect?
Well, I wouldn't put it like that. I wouldn't put it like either of the things you've just said, because I don't think that all consciousness is just affect. But I wouldn't say that feeling is an emergent property of consciousness. I'd put it like this. I'd say that the dawn of consciousness, in evolutionary sense of the word, was the capacity of an animal to become aware of its own state within a scale of values of goodness and badness of the kind that I just mentioned, where bad things are going badly feels bad, and things are going well feels good. So I think that was the foundational form and function of consciousness. But then there's a second step, which is I feel like this. That's the sort of fundamental form of consciousness. But then it becomes a matter of I feel like this about that. And so consciousness gets extended onto extraceptive representation and all the cognitions derived from it. I don't think that at that point you're talking about raw feelings anymore. You're talking about the extension, the application of raw feeling to the cognitive tasks that we must engage with if we're going to survive. In other words, perception and memory, perception and learning from experience how to solve life's problems. And the crucial issue here is that if we see affect as a demand upon the mind to perform work, in other words, as you deviate from your homeostatically viable bounds, you must do something about it. That's the demand for work. That's affect. Cognition is the work so demanded. So the work performed by cognition is not affect. It is the thing that affect triggers, that affect demands, that affect requires, but it is not itself affect. The crucial thing there is the predictions that we have, if I can use that term, which is so deeply bound up with Karl Friston's way of thinking. Predictions, memories are about the past, but they're for the future. The whole point of learning is to better predict the future. So the way I look on it is that our cognitive processing in toto is fundamentally to do with constructing a predictive model of how the world works and how I can meet my needs within it, and then testing that model. If I do that, I expect the following will happen: action, perception. And if what I expect to happen does not happen, then I have to update my predictive model, which is what learning is all about. Now, that cognitive work that I'm speaking about, this updating of our predictive model on the basis of the action perception cycle, that is the basic sort of principle that governs that, in my view, is that if things are going as expected, that's good. If uncertainty is prevailing, that's bad. And so that's the relationship between cognitive goodness and badness, rightness and wrongness, if you will, and affective goodness and badness. In other words, pleasure and unpleasure.
Right. And especially as you get to even higher level species, so I'm thinking like intelligent animals, it seems like good enough isn't good enough. That's why we've evolved curiosity, right? Even when you're completely content, there's something nagging at you that you want to go explore or do these other things.
You know, what you've just mentioned there is something that many people, it comes to their minds. You've put it very politely as oh, I see, that must be why the following happens. But most people put it more critically. They say, hang on a minute, if the mind is fundamentally homeostatic, then, you know, why don't we all just, you know, get into a dark room and do nothing? You know, everything's entirely predictable. That's not how we live. We are curious and we are interested and we engage with the world. We even take risks. Novelty seeking, you know, and so on, thrill seeking. What's all of that about, and why do we bother to study? You know, like we scientists do. And the answer in terms of the framework that I work in is that among the basic affective mechanisms, there's one. Different people give it different names, but it is the very one that drives the dream process. The mesocortical mesolimbic dopamine system the most common word for it is the brain reward system. But Panksepp called it the seeking system. Berridge calls it the wanting system. And Friston speaks of epistemic foraging. You know, and how it works, no matter what you call it, is basically this drive, this emotional need to engage with the world and to engage with what is not known, with what is interesting, with what is novel. It is a proactive engagement with uncertainty. In other words, to the extent that you do not have clear and present tasks like danger or rage or, you know, or hunger or suffocation or whatever, to the extent that your basic needs are currently more or less in kilter, then you have we click into this default mode, which is seeking, and it's basically an interest in the world and an engagement with what's new and what's not understood. As I said, Friston's lovely phrase for it is epistemic foraging, because what you're doing in that process is you are engaging with what you don't understand, with what you don't know, with what is unpredictable, uncertain. And in so doing, you are reducing uncertainty for the future, so that it's not going to bite you in the butt, because you know, when it comes at you, you've already engaged with it. So that's our understanding of why we seek, why we forage, why we engage with the world with this curiosity and interest and enthusiasm. We are not passive reactive creatures, and everything we know about this system suggests that it's pretty fundamental to the active, proactive engagement that we mammals display with in relation to our environments.
That makes a lot of sense. I think that's why I saw it as such a natural connection, because if we saw the brain as this basically predictive machine, then it's living for the future. So it only seems natural that you're going to have to prepare even when you're momentarily satisfied. I mean, that's right. The constant problem of delayed gratification. I guess some animals do it better than others.
You must couple what you've just said, which is all of it true. You must couple that with the endless unpredictability of the world. We are never going to be able to model the world so as to not be surprised by it. There's a hell of a lot more. What is that phrase of Shakespeare's? You know, there's more between heaven and earth than is dreamt of in your philosophy.
Yeah.
So your predictive model is never going to actually protect you against surprise.
So is most of your focus now on understanding the details of how cognition emerges from feeling, or are you more interested in the idea of how feeling emerges from no feeling?
Well, the question of how feeling emerges from no feeling for me coincides with how consciousness arises, you know, which is an absolutely foundational question. I think it is the question of all psychology. It is the question of mind-brain metaphysics. You know, I mean, how it is the question that I pondered as a kid. You know, I mean, how does it happen that subjective experience exists? Now, you must remember, at least within my way of thinking, the universe existed for a very long time before life emerged. And life existed for a very long time before consciousness emerged. So just those 2 points require us to be able to explain how consciousness emerges from biological processes that are not conscious. And that in turn requires us to explain how biological processes emerge from physical processes which are not biological. So I'm interested in this very reductive question. You could call it a reductionist program, but I think it is the most interesting question. When you say how does feeling arise, that is, how does consciousness arise? What is the causal mechanistic process whereby consciousness is constituted from things which are in themselves not conscious? So that is definitely the thing that interests me most. Now, how do we go about researching that? The great surprise in my own career, surprise to me, if not to anybody else, is that has made me interested in artificial intelligence. I was never interested in artificial intelligence precisely because I was never interested in intelligence. You know, we were talking earlier about anthropocentric perspectives, you know, and how we're so impressed with how the human cortex works because it's so clever. But, you know, I, for the reasons I've told you, don't believe that cortex is where it's at when it comes to understanding consciousness. And I think that consciousness is quite a simple thing. If its foundational form is just feelings, it's got nothing to do with intelligence. And therefore, you know, I was sort of familiar with what was going on in AI and AGI to the extent that all of us are, but I was never enamored with it because I thought it's missing the whole point. You know, these are not artificial minds. You know, if the mind is first and foremost something subjective, then, you know, I'm glad they're interested in what they're doing, and, you know, they can do all sorts of tricks, and it has all sorts of, you know, practical implications, but it's got nothing to do with the mind-body problem. When I became aware, as I said to you via Karl Friston's work, that actually it is possible to reduce the basic mechanism of affect, of feeling, to homeostatic principles, which are mathematically tractable, lawful principles. That made me take a new look at artificial intelligence and to think, well, if you really take seriously the idea that this is the causal mechanism whereby feelings are constituted, then you should be able to engineer it. In fact, I would go so far as to say that if you can't engineer it, then you haven't explained it. At least you haven't explained it in causal mechanistic terms. Richard Feynman, the brilliant physicist, when he died, it was discovered, I put it this way because it's not necessarily his last words. One doesn't know when he did it, but he wrote on his blackboard, and it was found on his blackboard after he died, a statement of his, which says, if I can't create it, I don't understand it. And I buy that. So that's what the main thing I'm doing now, mad as it seems. And I every now and then have to pinch myself or worse, and I have to sort of look myself in the mirror and say, are you mad, Mark Solms? What are you doing? But the thing that excites me most at the moment among the things that I'm doing is I'm working with a team of physicists, computer scientists, biomedical engineers, applied mathematicians. We're working on this question. Can we engineer an artificial consciousness? Mm-hmm. But please remember, when I say an artificial consciousness, I mean an artificial simple feeling whereby the agent, the artificial mind becomes aware of its own states in the sense of my energy supplies are dwindling. That's bad, etc. So that's what we're trying to do. It's an incredibly interesting and incredibly difficult project. difficult not only, in fact, not even primarily technically, because we're making progress in leaps and bounds on the technical side. But the difficulty is actually more than anything else epistemological. You know, it comes down to the problem of other minds. How do you ever know whether something else other than yourself is conscious? Because as we've said more than once in this conversation, you know, the crux of the embarrassing truth is that the mind is something subjective, which is why it's such a problem for science. If it's subjective, it means you can only observe empirically. You can only observe your own. I mean, this is the problem of other minds, and it's a gigantic problem. You can never know by observation that something else. I mean, I can't even, in this sense in the sense of absolute certainty, you know, ultimate knowledge. I can't be sure you're conscious. You look as if you are. You're acting as if you are. I infer that you are, but I can't observe it. Now, that problem is what haunts us in this project that I've just referred to. How can you demonstrate that your artificial mind has subjective states? This is a huge problem.
What is your take on panpsychism, the idea that subjectivity is a fundamental component of all matter and that it's built in?
Okay, well, remember what I said to you a few minutes ago. I said to you that consciousness presumably evolved. It evolved in living things, that there was a long time in which there were no living things. And panpsychism requires us to believe that, therefore, since the dawn of the universe, even before the earth formed, even before life evolved on earth, that at the dawn of the universe, there was something conscious. Now, that is the idea of God. You know, it's the idea that there is a fundamental property of the universe, which is sentience, that does not even require there to be living things. That's quite a claim. It's quite a out there sort of claim for which there is zero evidence, zero. So, you know, I mean, in these matters, we must all of us show a bit of humility, because they are metaphysical questions which we cannot answer by empirical methods, at least not methods that are available to us now. So I mean, I don't know. Maybe there's a God, and maybe there was some conscious presence that preceded the Big Bang. Maybe, but it ain't necessarily so. I'm more persuaded. The evidence suggests, you know, first of all, that all mammals are conscious. And we can go into that evidence if you like, but I think just listening to you, it doesn't seem as if you need persuading on that score. I think all vertebrates are conscious. It becomes less certain once you start dealing with creatures who do not share with us that brainstem anatomy, the reticular activating system, and periaqueductal gray. Those are crucial structures. When they are not there, I start to become less certain. But I'm perfectly open to the possibility that non-vertebrates are conscious. And then I would have to start speaking about functional criteria. In other words, other than anatomical ones, which is what we use, an anatomical analogy, because I know what this does in the human. You know, let me test predictions as to whether it does the same thing in the fish. Once you move beyond, where you move to species where there is no homologue of what we know to be consciousness generating in ourselves, I then shift to functional questions like, well, what is the function of consciousness? In a way, I have already told you my views on that, but I want to elaborate briefly. It is to me, basically choice. The point of feeling how you're doing, this is bad, this is good. The value of being able to do that is that you can navigate uncertain environments, unpredicted, novel environments. You don't have to have any pre-existing algorithm that when faced with this, I do that. What do you do when faced with something you've never been faced with before? Well, I don't know. Let's just random. And, some of us will survive and others won't. There's an enormous advance over that. If you can feel while doing it, this is leading to a bad outcome. This is leading to a good outcome. That, I believe, is the basis of choice. So voluntary behavior, for me, is capacity to make choices here and now. It's trial and error, and being driven by affects in relation to our various needs. There's not just one affect, feeling good and bad. There's multiple goodnesses and badnesses. But what I'm driving to is that any creature that can do that, that can make choices and survive in novel environments on the basis of those choices, I'm prepared to attribute, or at least to entertain seriously, the possibility that this creature has feelings. But why am I saying all of this? It's because you can carry on in that direction. What I've been talking about, all of this going down and down and down, trying to get to the bedrock of what is the mechanism, whereby consciousness is generated in the simple form I'm referring to. And you get to minimal criteria. Like, first of all, it has to be a self-organizing system. Homeostasis arises out of self-organization. That is to say, the requirement of the system to maintain its own existence. That's what and it's the behavior of the system is intentional. In other words, it has a goal. The goal is to carry on existing as a system. Before you can do that, you have to be a system. So, there has to be a boundary between the system and the not system, and so on. So these are the ways in which I end up, coming to minimalist criteria for what can and what cannot be conscious. A thing which doesn't have, which is not a self-organizing system. In other words, is not a system whose aim and purpose is to preserve its own structural and functional integrity. That does not have a me, not me boundary. In other words, there's no possibility of subjectivity because there's no boundary whereby the behavior of this entity is in response to the perturbations, the entropic perturbations in the environment. Beyond that, I think, well, it's just, I don't think that consciousness can exist. If consciousness is feeling, there's no functional mechanistic basis upon which it could exist. Those are the sorts of reasons why I'm not a panpsychist. I'll say one more thing. I'm sorry, I'm speaking a great deal. I'll say one more thing, about information, because what we're talking about, there's a fundamental concept in all of this, which is information processing. This is what the nervous system does. And when I speak of predictions and that predictive models, it's all got to do with, if I do this, I expect that will happen. Did it happen? This is all about information exchange between the system and its environment. There are some very brilliant people, like David Chalmers, for example, who claims that information just is, it has a subjective aspect and an objective aspect. And so the being of information is this fundamental property that we need to add to our ontology, and it exists, has always existed, and exists in everything. Tononi speaks of integrated information. For me, the crucial issue arising out of everything else I've just said about, first of all, you have to be a system and a self-organizing system before I would even entertain the possibility that you can feel like anything. You have to give a damn, to quote Dan Dennett. The system has to give a damn. The issue I'm leading up to is that information does not just exist in and of itself. Remember, this is me arguing against panpsychism. Information, if you think about Claude Shannon's introduction of information theory into physics, his famous paper of 1948 was entitled A Mathematical Theory of Communication. information has to be communicated. In other words, there has to be a source and a receiver of information. It is a response to a question. That's what information is. I flick a coin. Is it heads or is it tails? That's 1 or 0. That's a bit of information. That's the measure of information that's upon which all of the rest of information theory builds. So there has to be somebody asking, is it heads or is it tails? There's a question. Is it yes or is it no? Did it work or did it not? Is this good or is this bad? So the question asking is what the self-organizing system does. In fact, it is imperative that a self-organizing system asks questions. What will happen if I do that? So information is all about an agent that is asking questions of its environment and receiving information in return as an answer. So the idea that information just is sentient doesn't make any sense to me, because information is only information once you have an agent, once you have a system asking questions.
So everything you've just said, being a self-organizing system, being able to send and receive information, maybe everything aside from distinguishing voluntary from automatic, seems like it could even apply to plants, if plants sending chemical signals. And that's an observation, that's not a criticism. Like, I do think it would be very interesting to talk about whether plants have this exotic, maybe simple form of consciousness.
Well, I go back to what I said to you about the functional criterion. Mm-hmm. Look, let me just add, let me quickly add before I go down that route. I'm not a consciousness chauvinist, I'm the opposite of most of my colleagues. I mean, most of my colleagues say, well, you can only be sure that humans are conscious. I'm saying, are you crazy? All mammals are, and all vertebrates are. That I'm sure of. So I'm not, one to say, oh, no, I would never countenance the possibility that plants could be conscious. I would never countenance the possibility that all living things. I truly do countenance the possibility. I draw the line, at some point, but I draw it a lot further down the line than most do. But having said all of that, now coming back to your question about plants, the functional criterion that I use, not because it's the sort of deciding crucial test, but because it's the best I can come up with for now, is, can it make choices? Are its behaviors entirely predictable? In other words, is there a preordained algorithm which just runs its course? Because if it does, then I don't see what part feeling will play in this. I don't see any need for feeling. Feeling, as I told you, the great adaptive advantage of feeling is that it tells you here and now how you're doing. It's before it's too late. This is the wrong direction. This is the right direction. Plants, when I last looked, don't make choices. They're pretty predictable things. And it's also not hard to see why. I mean, they don't deal with the same. Their environments are far more predictable simply because they're rooted into the ground. Ambulation makes the world a much more unpredictable place. So, the kinds of biological problems that plants have to deal with are way more predictable than are the types of problems that we ambulant creatures, we animals have to deal with.
Mm-hmm. That's very interesting. So it seems like you might be making a case that consciousness is tied to free will. So if I want to be mindful of your time, but if you'd like, we could go down the free will rabbit hole, because to play devil's advocate, you could argue that human behavior is equally predictable. It's just massively more complex. So from the surface, it doesn't seem predictable.
Yeah. So what bearing in mind that I'm working within this Fristonian framework, which has to do with predictive processing, and that is ultimately an application of probability theory. It's all about statistical mechanics, prediction. It's not a yes/no business. It's what are the probabilities business. So bearing in mind that that's the broad framework within which I'm working, and linking it also to the other framework that I've mentioned, the affective neuroscience, these basic emotional needs, affective needs. We need to eat, we need to sleep, we need to get rid of frustrating impediments, we need to escape dangers, and so on. If that's the framework I work within. So now I've said all of that for a reason, which is the following. I think that free will is probabilistic. In other words, I don't believe that it's absolute. I don't believe we have absolute free will. I also don't think that we are deterministically driven in the Newtonian mechanistic sort of sense of the word. So to use a little analogy, metaphor, I don't know what it is, to illustrate what I'm talking about. The Bible story about Daniel and the lion's den. Daniel enters the lion's den. Well, that's free will, if there ever was free will, because look, he chose to go into a lion's den. My observation is, yes, but the chances of any of us going into a lion's den are very slim. So it is a very unlikely behavior. So this is what I mean when I say that free will is probabilistic. It is constrained by these homeostatic mechanisms, whereby as you deviate from your viable bounds more and more and more, so there is more and more determinism that governs your actions. They are the outliers, because it's all probabilistic. They are the outliers like Daniel, who say, I'm going into that lion's den, because there's some other thing that I hold to matter more. But that is just, as I said, the outlier. So that's how I see free will. So to come back to the way in which you're questioning my theory, when you're saying, well, isn't that ultimately what you're sort of saying is that it's just a very, very, very complicated algorithm? I would say, yes, I agree. Ultimately, it's a very, very complicated algorithm, but algorithms which calculate the sorts of things that we're talking about under the heading of voluntary behavior, there's certain constraints in terms of what is computationally possible. Have you heard of the combinatorial explosion? There's a certain amount of information that needs to be processed in order to answer, to predict every single possible situation. And it's just not plausible. I mean, it would take 5 years for the creature to be able to make a decision because there's so much processing required. So the kinds of solutions that have evolved are the sorts of things that we observe in affective neuroscience. Like, for example, there's a compartmentalization. There are categories of need, and you don't process them all with equal power. You don't process the uncertainty in relation to all of them. You relegate certain ones to automaticity, and then you select, okay, I'm scared. This is what matters now. And so consciousness is then dominated by this category of uncertainty, which is this working or is this not working in relation to escaping danger? Everything else then becomes automatized. So this is the view that I've been led to. That so do you see what I mean? It's not just a big complex algorithm. It starts to be an algorithm which requires, and this is absolutely crucial, it requires categorical variables. There's not just this thing called need. There are categories of need. There's the need to escape danger, the need to get rid of frustrating impediments, the need to stay close to caregivers, the need to eat, the need to blah, 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 blah. Each of those being a categorical variable, because remember, each need has to be met in its own right. You can't say total need. Let me just keep total need down. If you don't meet your energy needs, you're gone. If you don't meet your thermodynamic needs, you're gone. If you don't meet your hydration needs, you're gone. All of them have to be met. So each category of need has to be registered as a category, not as a continuous variable. And categorical variables are by definition qualitatively distinguishable. So, once you start speaking about this kind of algorithm, when you say, well, it's just a very, very, very complicated algorithm, but it's an algorithm which requires processing of qualitative categories, and it starts to sound like something more like sentience, and less like a predetermined, more like this palpating function, this feeling your way through problems that I'm referring to,
right.
and less like a big fat calculation that can in fact be pre-written.
So this ties in earlier with what we were talking about dreams, where you're dealing with this constantly changing unknown, and you have to keep re-updating your cognitive processes to keep up with that.
Exactly. As we said right at the beginning of this conversation, the interesting thing about dreams is that they're conscious. And I think that's the single most important thing about dreams is they're feelings in dreams. You're feeling your way through a problem. That's why they're conscious. Because it's a problem-solving process. The processing of the events of the day, the memory traces, in other words, the updates of my predictive model, which of these is going to be consolidated, which of these is going to be discarded. These are not things that we're indifferent to.
So is this categorical distinction and information processing, is this what integrated information theory is about? Is it like saying that the more complex something is, the more free will we can observe it to have, or the more conscious it might be? But in terms of, it's all continuous in the way that we're more conscious than other animals, and other animals are more conscious than a plant, but they all do have this same variability that we talked about, even if some are simpler than others.
Yeah, so I think that Tononi's way of thinking, is a lot closer to mine than, for example, say Chalmers's, or well, I don't need to name anyone. The point is, I think that we're in the same ballpark. But I must make plain that I'm not an integrated information theorist. I do not. There are important things about Tononi's ideas that I do not share. I mean, for one thing, he's not far removed from panpsychism. It's just a matter of how integrated is so utterly unintegrated information is a teeny, teeny, teeny bit conscious. And so phi, this quantity that he calculates, I think he pronounces it phi. It's never zero. So that is a panpsychist view. I don't share that view for all the reasons that I've already articulated. And for me, if I was to start identifying points of difference with Tononi, I would say, first and foremost, it's not just a matter of integration. It's to do with self-organization, that we're dealing with systems which have an aim and a purpose, which is to carry on existing as a system. There can be integrated information processing that has got nothing to do with that survival imperative. And I think that survival imperative is crucial. In other words, the self-organizing principle. Secondly, for reasons I've already mentioned and won't repeat, survival can't be computed over one quantity as a continuous variable, which is what phi is. It's a continuous variable. I think it has to be compartmentalized for the reasons I've said, for many reasons, but just the one I've mentioned, the combinatorial explosion alone requires it. But then also the fact that each need has to be met in its own right, because we complex creatures have multiple needs. And
is the number of compartments you can consider, is that a form of a continuous variable that has to be non-zero?
The number of compartments.
Right. So the bare minimum of categorical distinctions, a conscious
would be two. The bare minimum would be two categories. But I mean, you just look at, at any animal, you see that there are multiple categories of need.
Right.
There are multiple homeostats, and then there's this sort of meta-homeostatic function. But what I'm sorry, I see I'm sort of meandering from where we began, what you were asking me about integrated information theory. I was just trying to explain where I do not agree. And I think that it's not a matter of integration of information across the board. It's a matter of categories of information. And that doesn't exist in Tononi's way of thinking. In other words, it's all reducible to phi. And then secondly, as I say, this question of, well, what is the information processing for? And as I said, it must be for maintaining the existence of the system. And that doesn't feature in his formalisms.
So theoretically, the bare minimum for consciousness would be a self-regulating system that achieves self-regulation through at least a binary choice, if not a greater complexity choice.
It's not a binary choice. Sorry, I clearly didn't make that point properly. It's not a matter of a yes-no, in other words, a one-bit information question. It's a matter of categories of need where you have to calculate how well am I doing. In other words, my choices within this category are different from my choices within that category. So in other words, how well am I doing in relation to my need for water is a different question from how well am I doing in relation to my need for food. Once you've got to compute those categories as categories, in other words, you can't say, well, what is my total need? That would be a continuous, you have to have at least two categories of need for there to be a requirement of quality. You see, otherwise it's a purely quantitative question. So categorical variables, for me, are the ground zero of qualia. They require a qualitative distinction to be made in the calculations. That's the crucial point I'm trying to get across.
That makes sense. Great. Is there anything else from the hidden spring that you want to go over that we haven't covered?
No, gosh, it occurs to me now that you asked the question that you have very sort of effortlessly covered just about all the topics that book is about. So that's great.
Dr. Solms, thank you very much for your time.
Thank you so much for yours, Adam, and thanks for your interest.